Let's talk AI secrets. Hey everyone, and welcome back to Tech Curiosity Stream. We dive deep into the fascinating tech that shapes our world. If you enjoy untangling complex tech mysteries, hit that subscribe button down below. Today we are pulling back the curtain on something that is quietly revolutionizing the world of artificial intelligence: federated learning. Have you ever wondered how your smartphone keyboard gets so good at predicting the next word you're going to type? It learns from data, but whose data? Federated learning is a radical shift. AI gets smarter without hoarding our personal information in one place. Get comfortable, because you won't believe how this incredible technology actually works. To understand federated learning, we need to talk about the old way of doing things. For decades, the recipe for building AI was simple: get more data. Tech companies built gigantic data centers to collect everything they could. Your searches, shopping habits, locations, and photos were sent to a central server. This centralized training works, but at a massive cost: privacy. When data is piled up in one location, it becomes a tempting target. Data breaches expose sensitive information of millions. Many people are uncomfortable with their data being sent to a server they can't control. This creates tension between innovation and privacy. In healthcare, data is so sensitive that collecting it in one place is impossible. Data that could save lives is locked away because the risk is too high. This is the wall that traditional AI has hit. We want smarter AI, but also to protect our privacy. Federated learning flips the script. Instead of bringing data to the AI model, we bring the AI model to the data. The traditional method is like a master chef in a central kitchen. Federated learning is like the master chef sending a student apprentice to each home. The AI model sends a copy to your device. Your personal data never leaves your device. It sends a small, anonymous summary of what it learned. The central server combines these updates to create a smarter model. This improves the experience for all users without compromising privacy. It's a collaborative, decentralized, and privacy-first approach to AI. So how can we understand this idea? Let's use an analogy. Imagine a garden with thousands of flowers, representing all the world's data spread across devices. A central beehive wants to create amazing honey. Traditionally, it would move all the flowers, but that's messy and risky, like centralizing data. Instead, the hive sends worker bees. Each bee visits flowers, collects nectar, and returns only with the nectar. Your phone is a flower, your data is the nectar, and the AI model is the bee, learning without taking the flower. Back at the hive, bees share information, and the hive combines it to create honey. Federated learning does this. It takes updates from devices and combines them to create a smarter AI. The model learns from the entire garden, while the garden remains untouched. It's AI learning without collecting personal information. A sweet deal where data stays private. Let's break down the core principle: decentralization. Instead of one authority in charge, you distribute the power across many participants. In traditional AI, the server is the central authority, holding all the data and doing all the learning. This creates a single point of failure. Federated learning is all about teamwork. It creates a collaborative team where every participating device is a team member. Your phone learns from your data and sends its summarized update to the central server. This decentralized approach makes the system robust and privacy-preserving. There is no single treasure trove of data for hackers to target. It's about trusting the team members to do their part locally. In 2024, our devices generate more data than ever. Phones, cars, even fridges are constantly collecting information about us. The old way, centralizing all that data, means risking privacy, leaks, and surveillance. Federated learning changes the game. It lets devices get smarter without sending your personal data to company servers. In healthcare, for example, hospitals can train powerful AI models together without ever sharing patient data. This technology enables innovation while keeping privacy at the core. As AI becomes more central to our lives, federated learning is essential for a future that's both smart and secure. Let's break down how federated learning actually works. First, a central server selects a random group of devices, like your phone, when they're idle and plugged in. The server sends the latest AI model to these devices. Each device trains the model locally using its own data. Your data never leaves your phone. After training, the device creates a small, anonymous update summarizing what it learned. These updates are sent back to the server, not your raw data. The process repeats, making the global model smarter with every round, without ever exposing your private information. After local training, your phone sends a tiny, anonymized update, just the changes, not your data, back to the server. The server waits for updates from many devices, then averages them together. This way, no single update reveals anything personal. The global model improves using the collective knowledge of thousands while your privacy stays intact. This 5-step cycle, select, broadcast, train, report, aggregate, repeats constantly. Each round the AI gets better, learning from millions without ever seeing their private data. That's how federated learning keeps getting smarter, safely. Aggregation is the privacy engine of federated learning. Instead of collecting everyone's data, the server only sees averaged updates, never individual details. Imagine a room where everyone's age is averaged without anyone revealing their own number. This federated averaging blends updates from all users, smoothing out outliers and making the model robust for everyone. The result? A smarter, more inclusive AI that never exposes your personal information. It's privacy by design, not by accident. Federated learning goes beyond just keeping data on your device. Secure aggregation uses cryptography so the server only ever sees the final, combined update, never individual ones. Differential privacy adds a bit of statistical noise to each update, making it impossible to trace any change back to you. Even if someone broke through every layer, they'd find only meaningless fuzz. These techniques work together to make privacy a built-in feature, not an afterthought. Federated learning is engineered for security at every step. This sounds futuristic, but you're likely already using federated learning daily. A common application is your smartphone. Companies like Google and Apple use it to improve software while keeping your data on your device. Consider your phone's keyboard. It learns your slang and phrases. Your phone learns locally, then sends anonymous summaries while charging. This is combined with data from millions of phones. The collective intelligence improves the keyboard for everyone, learning new slang and names. It also improves your phone's voice assistant. Another example is image recognition. Instead of uploading photos, federated learning trains the model on your device. This improves search for all users without your photos leaving your phone. Beyond our smartphones, one of the most exciting and world-changing applications of federated learning is in the field of medicine and healthcare. As we've touched on, medical data is some of the most sensitive and highly protected information that exists. Privacy laws like HIPAA in the United States and GDPR in Europe place strict limits on how patient data can be shared. This is absolutely essential for protecting patients, but it has created a huge challenge for researchers. How can you train a powerful medical AI if all the data you need is locked away in separate, isolated hospital databases all over the world? Federated learning provides an elegant and powerful solution to this exact problem. Imagine a group of hospitals wants to collaborate to build an AI that can detect brain tumors from MRI scans earlier and more accurately than a human radiologist. With the old centralized method, this would be impossible. No hospital would be allowed to send all of its patient MRI scans to a central server. But with federated learning, they don't have to. The Central Research Institution can develop an initial AI model and send a copy of it to each participating hospital's secure internal server. The data never has to cross any firewalls or leave the hospital's control. Each hospital's server then trains its local copy of the model using its own patient MRI scans. The model learns to identify the subtle patterns that might indicate a tumor based on that hospital's unique patient population. After training, each hospital server sends back an encrypted anonymous update summarizing what its model learned. The central server aggregates these updates from all the participating hospitals to create a new, vastly improved global model. This new model has now learned from a diverse set of scans from different patients, collected on different machines from all around the world. It's a truly global expert. This process can then be repeated with the improved model being sent back out for another round of training. This allows medical researchers to build incredibly powerful diagnostic tools that can help save lives, all while maintaining 100% patient confidentiality. This isn't just a theory, it's already being used in practice. Research institutions are using federated learning to improve cancer detection, predict patient outcomes, and accelerate the discovery of new drugs. It's a technology that is breaking down data silos and enabling global collaboration on a scale that was simply unimaginable just a few years ago, promising a future of smarter, more personalized medicine for everyone. The applications of federated learning don't stop with phones and hospitals. This technology is becoming a key ingredient in the next wave of smart technology, especially in the automotive industry and the broader Internet of Things or IoT. Think about modern cars. They are no longer just machines, they are computers on wheels packed with sensors that collect a huge amount of data about their performance, the road conditions, and the driver's habits. This data is incredibly valuable for improving safety features, optimizing fuel efficiency, and developing self-driving capabilities. But it's also highly personal. Let's consider the challenge of building a truly smart self-driving car. The AI needs to learn how to handle an infinite variety of edge cases, rare and unexpected events on the road like a deer jumping out or a confusing construction zone. To learn this, it needs data from millions of cars driving billions of miles in all sorts of conditions. The centralized approach would require every car to constantly upload massive video feeds and sensor data to the manufacturer's servers. This would be a privacy nightmare and would consume an enormous amount of bandwidth. It's simply not a practical or scalable solution. Enter federated learning. A car manufacturer can push a model update to its fleet of vehicles. Each car can then use its own driving data to improve the model locally. For instance, if a car successfully navigates a tricky, poorly marked intersection, it can train the model on how it did that. It then sends a small, anonymous update back to the manufacturer, summarizing the lesson learned about that intersection. The manufacturer can aggregate these updates from thousands of cars that have driven through the same spot, creating a much more robust understanding of how to navigate it safely. This allows the entire fleet to get smarter over time without compromising driver privacy. This same principle applies to the entire world of smart devices. Your smart thermostat can learn your heating and cooling preferences without sending your daily schedule to a server. A network of smart home security cameras could learn to better distinguish between a pet and an intruder without sending video of your living room to the cloud. By bringing the learning to the device, federated learning allows for a future where our connected world becomes more intelligent, more responsive, and more helpful, without forcing us to trade our privacy for that convenience. It's building the foundation for a smarter, and more importantly, a safer connected world. Federated learning offers massive, game-changing benefits. The most important is privacy. By keeping raw data on your device, federated learning changes the relationship between you and companies. It moves us away from our personal information being the price we pay for innovation. It's a revolutionary shift in how we handle personal data, enhancing security. Companies no longer need to collect massive data troves, reducing the target for hackers. There is no central honeypot of personal information to steal. Beyond privacy and security, this approach unlocks new possibilities. Fields like medicine and finance can collaborate in ways previously impossible. We can improve public services while upholding data protection standards. It's a win for innovation and individual rights. Federated learning is more lightweight, sending only small updates. This saves energy and makes the process more sustainable. Federated learning, while amazing, isn't a magic bullet. It presents unique challenges and complexities, making implementation harder than centralized approaches. Statistical heterogeneity, where data varies across devices, is a major hurdle. This diversity, while a strength, can skew the global model if some devices have wildly different data. Communication is another challenge. Slow, unreliable internet and dropped connections can create bottlenecks, slowing improvement. Federated learning is a marathon. The system is complex to build and maintain. Data is hidden on millions of devices, making it difficult to diagnose problems. This brings us to one of the most fundamental trade-offs in federated learning, the constant balancing act between model performance and user privacy. In an ideal world, we would have a perfect AI model and perfect absolute privacy. But in the real world, these two goals can sometimes be in tension. The very techniques that are used to enhance privacy can, in some cases, slightly reduce the ultimate accuracy or performance of the final model. It's a delicate compromise that engineers and researchers are constantly navigating, trying to find the sweet spot that gives us the best of both worlds. Think about the technique of differential privacy that we discussed, where a little bit of statistical noise is added to each update to protect individual users. This is a fantastic tool for boosting privacy. However, adding noise, by its very nature, means you are slightly obscuring the true signal from the data. If you add too much noise, you can protect privacy so well that the server can't learn anything useful at all, and the model's performance will suffer. If you add too little noise, the model might get smarter faster, but the privacy protections become weaker. Finding that perfect, Goldilocks amount of noise is a major area of ongoing research. Another aspect of this trade-off involves the complexity of the models themselves. The most powerful state-of-the-art AI models are often gigantic, with billions of parameters. These enormous models can be too large to efficiently send to a user's phone, and they can be too computationally expensive for a phone to even run a training session on. As a result, federated systems sometimes have to use slightly smaller, less complex models that are more practical for a decentralized environment. While these models are still incredibly powerful, they might not quite reach the absolute peak performance of a massive model trained in a giant data center with unlimited resources. Ultimately, the goal is not to achieve perfection in one area at the expense of the other. The goal is to build systems that are good enough on all fronts, systems that provide excellent, useful performance while offering strong, meaningful privacy protections that users can trust. This is a dynamic and evolving field. Researchers are constantly developing new techniques like more efficient compression for model updates and smarter aggregation strategies that push the boundaries and reduce these trade-offs. The journey of federated learning is about continuously refining this balance, creating AI that is not only smarter but also safer and more respectful of us, the users. We've journeyed through what federated learning is and how it works, but the story is far from over. The future is buzzing with exciting possibilities as researchers work to make it even more powerful, efficient, and secure. One major innovation is unsupervised federated learning, finding hidden patterns in unlabeled data to unlock new levels of AI intelligence. Another frontier is efficiency. Future versions are exploring ways to compress model updates and developing asynchronous systems to speed up learning. We're also likely to see fully decentralized or peer-to-peer federated learning, where devices coordinate directly without a central server. Finally, security and privacy are getting a boost with fully homomorphic encryption, creating an almost unbreakable fortress of privacy. Federated learning can reshape how we think about personalization and collaboration. Imagine a personal health assistant on your smartwatch, providing personalized health advice without your data ever leaving your wrist. Think about tackling climate change with a federated network of environmental sensors contributing data to build accurate climate models. Federated learning provides the framework for humanity to pool its knowledge to solve our biggest problems. Federated learning could democratize AI, allowing smaller companies to develop powerful AI services. Ultimately, it's a future where we don't have to choose between smart technology and a private life. We are moving towards a connected world that is more intelligent, helpful, and respectful of our privacy. We've explored federated learning, starting with the problem of data hoarding and privacy risks. We uncovered federated learning as an elegant solution. Instead of moving data, we bring the algorithm to the data, enabling devices to collaborate for smarter AI while protecting sensitive information. Extra security layers create a fortress to protect our data. It's powering smartphone keyboards, transforming medical research, and paving the way for smarter cars. Researchers are building a future with more efficient and secure systems. It's key to a future of innovation and privacy. Subscribe and ring the notification bell so you don't miss our next adventure. See you in the next video. Stay curious.